Okay, so in the last video, we just covered the key definitions. And in this video, we're going to cover how to apply the key definitions, okay? So if you have any questions as we're covering this video, please feel free to comment on the video or in Google form, ask your question. Okay, my apologies. Stabilized, centered, okay, somewhat centered. Okay. So we're going to talk about sketching quadratic functions. Now I'm going to sketch them on this. You can sketch them on your paper or somewhere else. So it is talking about sketching graphs of quadratic functions, y equals x squared, and comparing it with f of x equals 1/3 x squared. Now, if you notice, what changed was that 1/3. So we've already covered transformations before. So 1/3 would be a vertical shrink. Shrink means it gets wider. So actually, if you made a table, right here, this beautiful thing, and we did what? -2, -1, 0, 1, 2, right? Did our nice little thing, plugged it in, we get 0, 1, 1, 4, and 4, right? But if we plug in this 1/3, what's going to happen? Well, f of x is going to be a little bit slightly different. It's going to be 4/3, 1/3, 0, 1/3, and 4/3. Now notice 4/3 and 1/3 are smaller than their counterparts on this y right here. Okay, and if also we did g of x right below it, if we're just doing a table, we would get what? 4, so that would be 8, 2, 0, 2, and 8. So that g of x, that 2 times x squared, is going to grow even more than our original function. Okay, so this is a vertical stretch, vertical shrink, and what would they look like on a graph? That is a great question there. I don't know who I should pick on, but I'm not going to pick on you as much as I should. So all of you can be thankful. While I'm drawing this, you could be sitting there going, why does Mr. David always choose to draw his graphs too small? That's a great question. The answer of that question is that he does not predict what the graph will look like before he starts it, or how high he needs to go before he starts his graph. Okay, there we go. So if we look at our original, our parent function, as it were, we would have this graph right here. Now, if you remember me teaching you from Algebra 1, I was very picky about perfect graphs. And then I grew older, and you guys grew older. So the graph is not going to be perfect. Okay? So that's our parent function. Now, what does our f of x look like? So we'll look here, and 4/3 is just barely over 1/3, so it actually gets wider right there. Same thing over here. Same thing over here. So our graph just naturally, our f of x is going to go wider. Okay, do you see that? So this is our parent function. This is our f of x. And you know, if you're just like, Mr. David, please make this look more exponential. Okay, I'll try. Then the next one, this vertical stretch, is going to actually look pretty thin. If you're trying to compare yourself to a thinner person, just realize maybe they just stretch more than you. And there's my math humor for the day. Okay. Okay. So if you notice, vertical stretch right there, vertical shrink right here, and our parent function. So that is going to be how to graph the quadratic. Okay, pretty simple. Now, standard form. We're actually going to change this into standard form. This one, the 2x squared plus 8x plus 7. And this is actually the process that I want you to know. So those graphs of stretches and shrinks doesn't matter anymore because we have stopped caring. Okay, that's not true. We still care. Okay, x. Okay, what we're going to have to do is actually, we are going to have to set it up as our standard form, okay? So what we actually have to do is get these two by themselves, so that's separated. So what you're going to have is you're going to have 2x squared plus 8x. And the beautiful thing with algebra is that you are always able to separate this. And once we separate this, we can divide out this 2, move it to the outside, so we get 2x squared plus 4x. Now, we can always complete a square by adding something on the inside and subtracting it on the outside. So how do you complete the square? Well, we divide this by 2. That's 2. 2 squared is 4, so we can put this in. But if you add this in the inside, you have to subtract it on the outside. So if you added 4 here, you have to remind yourself that you have to also multiply by 2. So 4 times 2, 8, so we have to subtract 8 on the outside, okay? So once you do that, then we're just going to rewrite it. So we have and then 7 minus 8 is just minus 1. Okay, this right here is something that you can call a perfect square, or rather, you could turn it into this thing right here, okay? So what you're going to get is you're going to get 2 times x plus 2 squared, okay? That's just me rewriting it, okay? It's essentially the same thing, it's just changing it into this form right here, okay? That's what completing the square does. So if you're confused about completing the square, we can practice some stuff. Okay? Now, what did they ask us? Identify the vertex and axis of the parabola. So the vertex is going to be our h, comma k. Okay? So what's h? H is actually negative 2. Okay? And k is negative 1. Okay, do you see how this is minus h right here, and this is a plus? That would mean this is a minus. Sorry, there's a little bit of a glare. So that's our vertex, and axis is going to be x equals to h. Well, h is negative 2. So axis of symmetry is going. I like to call the axis of symmetry our AOS. So our AOS is x equals negative 2. Okay, vertex is negative 2 comma negative 1. So that is how you do that. Now, if you want to graph this is actually very simple. You will plug in 2 points to the right or to the left, and then you just use your symmetry to write it to the opposite side. So if you're going to graph this, it's pretty simple. So if you're going to graph this function, take this, take this, take this. Now, this might be way too big for what I just did. So we start with, we're at negative 1, negative 2. Okay, that's our vertex. Okay, then we have our axis of symmetry. Okay, so if we plug in 1 point to the right, which is negative 1, in here we get 1 squared, so that's 1, times 2, 2, minus 1, 1. So we go up 1, so we're here. And then if we plug in 0, we get 2. 2 squared is 4. 4 times 2 is 8. 8 minus 1 is 7. So 1, 2, 3, 4, 5, 6, 7. It's 1. And so our next point's here. So what's going to happen if we have that on the right is the same thing's going to happen on the left. And that's a little bit higher. My apologies. And then Okay? Now, if you were, guys, if you're labeling it doesn't mean label the graph, it means label on the side here. Okay, this thing right here that I did. Okay, that's labeling. So don't label your graph with, well, AOS is here and our vertex is here, because the reason is that I will not pay attention to that. Okay. Now, here's our next function. How much time do we have? Okay, we're going to have one more video, so we're going to do one more question with this, and then in the video I'm going to talk about maximum. So I'm actually, I'll go through those 2 points quickly. Okay, next video.